All right, everybody, hello and welcome back. Today what we're going to do is we're going to work on understanding what rational exponent form is and what radical form is. And we're going to work on transitioning between the two. All right, so the first problem I usually start with is we take a problem like this, the square root of 16. This is what we call radical form, because there is a radical. In this case, it is a square root. So normally what I try to do is I try to get my students to think about, okay, I know in my head that the square root of 16 is going to simplify to 4. However, what I want you to do is start to think about, let's see if I can, what power of 16 will give you the same thing. All right, so what I mean by that is we know that the square root of 16 is 4. Now what I want you to do is think about 16 to what power is also going to give us 4, because we want to transition into what we call rational exponent form. Now many students typically start off by guessing and checking, which is absolutely fine. You could use a calculator to help you out. Usually what we end up with first is the idea that when we raise 16 to any whole number power that is positive, we end up getting a bigger number. And we know that we want a smaller number, right? 4 is smaller than 16. So we know that a positive number greater than 1 is not going to work. The next guess I usually get is a negative number. All right, but we got to remember our negative exponent property tells us that what this really is it becomes 1 over 16 to the second power. All right, so that is going to be 1 over 16 squared, and that's going to be a very small number. Again, still not 4. All right, so we've already tried to do positive numbers. We've tried negative. What we haven't done is any fractional values. All right, and the way that this works is we have 16 to the 1/2 power is going to give us 4. All right, so radical form is the one with the square root here, and then our rational exponent form would be 16 to the 1/2 power. All right, and the real reason this is because a square root has almost an imaginary 2 there. What it tells us is we are looking for what value times itself is going to give us 16. And that's why 4 works, because 4 times 4, there are 2 of them, that gives us 16. So the idea is if we are taking the square root of something, there's an imaginary 2 there. All right, so that helps us transition to rational exponent form, which is 16 to the 1 over 2 power. And again, you can check that in your calculator and it should work out as well. All right, here's another problem for us that should kind of help drive home this idea. So we have the cube root of 27. Now, a cube root really means we are looking for 3 groupings of one number. So if we jump back over here real quick, we had the square root of 16. Well, really what we're doing is the square root of 4 times 4. Again, there's an imaginary 2 right there that we don't write, so we're looking for groups of 2. There's a group of 2 right there, 2 4s, and therefore our answer is just 4. So same idea here. A cube root is trying to figure out what value cubed is going to give us 27, or we are looking for groups of 3. Now, coincidentally for us, we have a group of 3, and that value is 3. So the cube root of 27 is 3. Now, we need to think about the same idea. We have the radical form, right? In this case, it is a cube root. But we want the rational exponent form. All right, so 27 to what power is going to give us the same thing as the cube root of 27, which was 3. All right, so let's use the same idea we did over here. There is an imaginary 2 here that we don't have to write with the square root, and our rational exponent form was 16 to the 1 over 2. So using the same thinking, this should be the same thing as 27 to the 1 over 3 power, because again, this number right here should match that number and is the bottom of our fraction, just like it did over here. This number here should match the bottom part of that fraction. And that is how we essentially rewrite from radical form into rational exponent form. And we can kind of go back and forth. It doesn't really matter where we start. You should be able to easily transition between the two. Now, the main thought process that we use here is this idea that we have some value a to the m over n power. Well, if we're going to do rewriting and simplifying, we need to use our exponent properties. Technically, this is the same thing as a to the m raised to the 1 over n power. And that tells us because the power property of exponents would require us to multiply these two values. Well, if I do that, I should get m over n in our exponent. All right, and you'll see why in a little bit this is helpful. Now, we could also rewrite it like this. A to the 1 over n power all raised to the m power. Exact same idea, because this should also simplify to m over n in our exponents. All right, so we're going to work on transitioning between the two, and we're going to use this idea here to help us simplify different values. So first we have 32 to the 3 over 5 power. Now that looks very confusing to us, but let's remember that we can separate these two things. So we can separate it so we have 32 to the 3rd power, all raised to the 1/5. Now, that doesn't really help me because I don't know what 32 to the 3rd power is off the top of my head, and it's probably going to be a very big number, which is going to make this difficult. But if we remember, this can also be rewritten as 32 to the 1/5 power raised to the 3rd. Well, that's a little bit easier for us because raising something to the 1/5 power is the same thing as taking the 5th root of that value. And what that means is we are trying to think about what value to the 5th power is going to give us 32. Hopefully we know that that answer there is 2. So we can rewrite that and simplify the 5th root of 32 as the number 2. And now we have 2 to the 3rd power, which is really 8. So our answer of 32 to the 3/5 power is going to simplify to 8. All right, so we're using a lot of different ideas here. We are using exponent properties to separate the two values in our exponent, 3 and 1/5. And then I'm trying to think about which one would be the easiest for us to do, and I settled on 32 to the 1/5 to the 3rd. And the reason that is raising something to the 1/5 power is the same thing as taking the 5th root. And that's something I can mentally think about a little bit easier. What value to the 5th power is 32? And my answer was 2. 2 to the 3rd then simplifies to 8, and I get my final answer. Now, we're going to do a similar idea here. We have the square root of 8 to the 4th power. Now, the square root of 8 does not simplify as easy as we might like. So what I'm going to do is I'm going to switch from radical form inside those parentheses to rational exponent form. I'm going to rewrite this as 8 to the 1/2. And again, we remember that it's a square root, so there's an imaginary 2 there that we don't really write normally, but it's something that helps us transition from our radical form to our rational exponents. All right, and we can't forget we've got that 4 on the outside. Again, I'm not really sure how to simplify here because 8 to the 1/2 power is a square root of 8, which is not a nice number. But hopefully we recognize that we should be able to do something here. And what I can do is I can combine those exponents. So I'm using my power property, and I have 8 to the 4 times 1/2, or 4 over 2 power, which is really the same thing as 8 to the 2nd power, right? 4 over 2 is 2. So 8 to the 2nd power is going to give us 64, and that is our final answer. So again, we are transitioning between radical form in the beginning to rational exponent form, because then we can use exponent properties to combine the 1/2 and the 4 and simplify from there. So that is typically how we are going to do these types of problems. We are going to use our exponent properties and rational our radical properties, excuse me, to simplify and kind of get it to a place where we're a little bit more comfortable with. Now, the ultimate reason we are doing this is because we are going to want to solve equations, and we're going to use some of those skills. So for example, we have 5 times x to the third power is equal to 320. Now, I need to solve for my x value, so what I'm going to do is I'm going to divide by 5 first, just using my regular approach to solving an equation. I want to isolate that variable. So I end up with x to the third power is equal to 64. Okay. Now I've got x to the third power is going to equal 64. So there's a couple ways I can do this. We can think about what to the third power is 64, but what I can do is use those properties. I know that I want to get this to become a regular x. That means the exponent needs to be 1. Well, if I multiply my exponent by 1/3, that will allow my exponent to simplify to 1. So I'm going to do the same thing to the other side as well, raise it to the 1/3. Now, what that really is doing is that means I am taking the cube root of both sides, which allows me to simplify. And for me, it's a little bit easier to think about than 64 to the 1/3 power. The cube root of 64 is saying, hey, what value to the third power is 64? And my answer here is 4. So I know that x is going to be equal to 4. Now, let me kind of run through that one more time. I started off with the same approach I normally would for any other problem. I start to isolate my variable as much as I can by dividing by 5. Now, when I did that, I was left with x to the third power is equal to 64. I knew that I wanted to get x to the first power, so I needed my exponent to become 1. Well, 3 becomes 1 by multiplying by 1/3, so I raised it to the 1/3. And then I had to do the same thing to the other side. Well, raising something to the 1/3 power is the same thing as taking the cube root, which allowed me to simplify from there. I took the cube root of both sides. These two values multiply to give me 1, which is what I have down here. And then the cube root of 64 is saying what number to the third power is 64, and my answer was 4. Okay? This one over here is going to be pretty similar for us. All right, what we are going to do is we are going to have to isolate that variable. The problem is it is inside those parentheses and there's an exponent. So I need to get rid of that exponent. Well, the only way I can do that is by raising it to the 1/4 power. And the reason that is because then my exponents will multiply, I'll get 1, and I don't need the parentheses anymore. Well, if I do it to one side, I'm going to have to do it to the other as well. Technically, what that means is I am taking the 4th root of both sides. All right, and the reason I wanted this is because on my left side, the radical and the exponent of 4 cancel, so I'm left with x plus 3. And really, I don't need those parentheses anymore because my exponent is just 1. And now I have the 4th root of 32, so it's saying what number to the 4th power, is going to give me 32. Well, that's a little bit more complicated here because I don't think that is going to simplify evenly. So I need to break up 32 into factors here and try to find a group of 4. Well, I know that 32 is really 16 times 2. And I also know that I can simplify the 4th root of 16, but I can't simplify the 2. And the reason that is, and let me maybe rewrite it as such, is 16 can be written as 2 times 2 times 2 times 2. We can't forget we've got that extra 2. So these two things are really equal here, and I am looking for groups of 4. That is what that's telling me. So I've got a group of 4 right there. So I'm left with x plus 3 is going to be equal to, I have 1, 2 that gets to leave, and that's where those 4 come into play. And I've got 1 that is stuck on the inside. Now the last thing I'm going to have to do is remember, first of all, because this is an even power and I am simplifying and solving, I'm going to need a plus and a minus here. What that means is when I subtract my 3 over, I get x equals -3 plus or minus 2 times the 4th root of 2. And now this is going to be my answer. So it's a little bit more confusing in this case, mainly because my radical did not completely simplify. All right, that kind of confused things for us and required us to break down that value to search for, in this case, groups of 4. All right, second of all, because the exponent was even, I needed a plus and minus. I did not need a plus and minus here because I knew it had to be a positive 4. Now, if it was -4, I'd have 3 of them, and that gives me a -64. So the only way that that works is if it's positive 4. That's why this one did not need a plus or a minus. All right, so for the most part here, what we are going to have to do is we are going to have to use the idea that we can transition between radical form and rational exponent form to use those rational exponent properties and simplify. This is a perfect example of what we were doing right here. And even up here, we've got some good understandings of how we can split up those exponents, switch forms to help us simplify, and kind of transition from there. All right, so the main tip that I want you guys to take away from today is, first of all, how to transition between the two forms. And then this idea right here is going to be very helpful for us later on. All right, we will use this as we simplify as we go. If you have any questions, as always, please feel free to reach out. You can send me an email or leave a comment below. All right, thank you.